in this video I'm going to go through how we discovered the properties of logs. And so we're going to evaluate each expression without a calculator and just compare some things and see what we find. So first one, log base 2 of 4 is 2 plus log base 2 of 8 is 3. So this expression will be 5. Remember, we're asking 2 to the what power equals 4 and 2 to the what power equals 8. And so then if we compare with this expression, 2 to the what power equals 32 is 5. And so this isn't a coincidence that these are the same. Let's look at two more and then come up with a conjecture, which is something that we think is going to be true always about logs. So log base 3 of 27, 3 to the third power is 27. Log base 3 of 3 would be 1, so this expression would equal 4. And then this one would also be 4 because 3 to the fourth power is 81. So then when we compare the numbers inside the parentheses, what do we notice? So compare the 4 and the 8 and then the 32. And maybe you see that 4 times 8 is 32. And here 27 times 3 is also 81. Whoops, 27 times 3 is 81. And so the conjecture here, if we put anything in here, say x, and then a different number in here, we can combine two logs into one if we write it x times y, whatever this number is times y, and we can do what's called combining logarithms. Okay, so this is called the product property, and it's very similar to the exponential property that says if you have a exponential with a to the x times a to the y, that you add those exponents. Okay, number 2, log base 4 of 64 is 3 minus log base 4 of 16 is 2, so this expression equals 1. And then log base 4 of 4 is also 1. And we keep going. Log base 3 of 9 is 3 minus log base 3 of 27, we just did that, is 3. Sorry, this one is not 3. 3 to the what power is 9? 2. So this expression is negative 1. And log base 3 of 1/3 is also negative 1. 3 to the minus 1 means 1 over 3. So now, this isn't a coincidence that these are the same. Let's analyze the number inside the parentheses, 64 and 16. What could we do to get a 4? 64 divided by 16 is 4. Does that work here? 9 divided by 27. Does that equal 1 over 3? Yeah, it does, because 9 goes into 27 3 times. And so we get this second conjecture, or the second property. If we plug in any number here, x, and this number, y, something different, and we're subtracting, we can combine two logs into one if we divide those, x divided by y. And this is called the quotient property. And this is similar, again, to the quotient property of exponents that says if you have a to the x divided by a to the y, then you subtract the exponents. Okay, last one. 3 times log base 2 of 2. Well, log base 2 of 2 is 1, and then we do 3 times 1 is 3. Okay, and then this expression, log base 2 of 2 cubed, 2 cubed is 8. So if I rewrite this log base 2 of 8, then I say 2 to the what power is 8, and that's also 3. Okay, so the next one, 2 log 10. Well, log 10, that means base 10. So this is just equal to 1 times 2 is 2. And then 10 squared is 100. So this really means log of 100, which is also 2, because 10 squared is 100. So now what's going on here? Maybe we can see. Notice if from this expression, this number is just put inside the exponent here. This 3 used to be here. And same with this. This 2, if we move this over here, it looks just like this expression. And notice those expressions are equal. So if we do this here, move this 3 into here, it would look the same as this one. So we're claiming that these are going to be equal again. Well, log 10 is 1 times 3 is 3. So this should be 3. 10 cubed is 1,000. Log of 1,000 is 3. So we get this last property called the power property that says we can take this n and move it into the exponent. And so we would get log x to the n. Okay. So those are our properties, 3 properties of logarithms.